Alright, so we're going to take a tour of this aircraft where there are several levels of assembly information passed from the top level downwards. Now, there are plenty of ways to go about this, and a lot comes down to personal preference. But let's take a look at how this one is laid out. And as it is, it's at the stage where it has its outer surface defined, as well as some structural outer surface and parts. But it's missing still a lot of its bottom level parts. So let's take a look at how we would design from the top down towards a rib in the wing assembly of this aircraft. So let's start by visualizing the sketches and hiding the parts that are done so far. So we have at the top level, we have some sketches that just kind of lay out what the aircraft will take shape within. So one of those is just the dihedral. And the way that I laid out this aircraft, I'm assuming or forcing the origin to be the CG. So as I'm designing, I want to make sure that as I'm putting in parts and moving them and changing their shape, the CG stays around this area, especially fore and aft. Not necessarily, it doesn't matter quite as much top down, but this is where I'm assuming the CG is at. So we have a dihedral layout, so this is a low wing. The wings are starting lower than the CG and ending a bit higher. We have the passenger layout. This aircraft is from, I think it was 2017 when, or 2018 when there were tennis balls as passengers for the SAE competition. Then a landing gear layout. So this is defining, so where the wheel is at least you clear at least 15 degrees. You might even want more for where the fuselage and empennage end, so that the aircraft can pitch upwards and none of the aircraft can be below this line. Otherwise it could hit the ground as the aircraft pitches up. And then we've got, so when it's at this maximum pitch up, we want to make sure that the CG is at least a little bit forwards of the line of force that the wheel produces when the main gear hits, so that the aircraft doesn't have a aft pitching moment when it hits. And then there's also some angles defining where the nose gear should be, so that it has about the right amount of weight on it. And that's pretty much it for the landing gear layout. And then a wheelbase. So this is just some sketches that can help orient where the parts are going to end up. Oh, it doesn't necessarily define the shapes of them entirely, but the dihedral will define where, for instance, the plan form of the wings plane is and all that. So then I've put an OML, and this one I've used some frames that make sure they clear the passengers as well as the cargo. So those are referring to a few of the top level assembly geometry. And each of these surfaces I've done is sort of components of the overall OML. So or segments of it. So this is not exactly what the end OML will look like, but each of them kind of interferes or has gaps, but these are the sort of elements that form the overall OML. in the actual subassemblies. So after that, I also have a structural OML. So especially the most complicated part is where the wing and the fuselage meet. So that takes reference of the wing OML to define, so these are projections of the wing OML, these are lines to define sort of how big can we make this wing box, and to position it so that it is approximately in the middle and has about the same amount of clearance on both sides for the ribs the whole way through. So that defines some structural parts down the line. Then we have the actual assemblies with the actual parts in them. So for instance, if we show the fuselage here, it's using OML from the wing and from the fuselage and from the root wing fillet, but inside the OML of the fuselage, there's a lot of surface work, smoothing and trimming that sort of copies surfaces from the original OML and then smooths and trims them in a way that sort of the generation of the first elements that you're going to use, and then the smoothing and trimming is in two different parts, two different steps. So we can change the OML of the aircraft, and the fuselage assembly will change as well. But all of that smoothing and trimming is left into the assembly, into the fuselage assembly itself. And obviously we cut off, it's not going to use any of the portion external of this wing, it's not going to use the empennage. So same thing with the wing. If we go into the wing subassembly, I have the fuselage. That's only from here on out, and the cuts for the control surfaces and all that are defined in the overall OML. So yeah, if we were going to make a part here in the wing assembly, what we could do, so we've already copied in the wing assembly itself, we already have the portion of the surface from the OML that we need. So if we go back into the full aircraft, I mean, we could hide the overall OML. And these parts that are created from references to the surface OML are already there, so we can hide those. And we can work directly in the wing assembly. So we've got structural elements and the wing OML. So if we were making a rib, what we could do is just put in a new part, float it. We could mate front with front. Oops. We could mate front with front. Top with top. And the wings top plane is actually the dihedral plane in the overall assembly. So then the right plane, we can mate with the right plane, and let's say, usually we would do this with a layout, we wouldn't actually use a distance mate, but I mean, for the purpose of this video, let's just use a distance mate. So we're going to, now this part is constrained, then we can edit it, and in its right plane, we can sketch, then we can grab, so we're grabbing the the OML, which is passed. So it's passed from the assembly general OML to the wing assembly OML, then to a rib. And we can also grab outer surfaces of the structure. And that could be the start of our rib. Oh, it's not closed yet, we just need to. So once we have those references in this sketch, editing it in context anymore and trying to fix all those things, those little gaps, I mean, we want to make sure we're not referencing to more things we're not sure of. So we can open it in its own part and then close them in here. There we go. So that could be the start of our rib. And show everything else for context, but not these two. So top-down design, it does allow for a more streamlined approach to complex designs. We just have to make sure to organize and manage our external references so they don't become a hassle and get really confusing. So to do that, we generally want to stay in bottom-up, except for where top-down is really beneficial. So in the next video, we're going to go through some general guidelines to keep in mind, not always obey, but to keep in mind while using top-down design for your aircraft.